Drew Boyce.
The science guy.
Drew Boyce.
The science guy.
Drew Boyce.
The science guy.
Science rules.
Okay, let's say you have a cube of sugar. If you take that cube and crush it up, you just have smaller, tiny particles of sugar just built into the cube. However, let's say you take some more sugar, and you take that and you jump into water. The sugar almost disappears completely. Says right here, observations like this led early philosophers to ponder the fundamental nature of matter. Is it continuously and infinitely divisible, or is it divisible only until a basic invisible particle that cannot be divided further is reached? The particle theory of matter was supported as early as 400 BC by certain Greek thinkers such as Democritus. He called nature's basic particle an atom, based on the Greek word meaning indivisible. Aristotle was part of the generation that succeeded Democritus. His ideas had a lasting impact on the Western civilization, and he did not believe in atoms. He thought that all matter was continuous, and his opinion was not accepted for nearly 2,000 years. Neither view of Aristotle nor that of Democritus was supported by actual evidence, so each remained speculation until the 18th century. Then scientists began to test out matter. So virtually, all chemists in the late 1700s accepted the modern definition of an element as a substance that cannot be broken down further by ordinary chemical means. It was also clear that elements combine to form compounds that have different physical and chemical properties than those elements that form them. There was a great controversy, however, as to whether elements always combine the same ratio when performing a particular compound. The transformation of a substance or substances into one or more new substance is known as chemical reaction.
Fun fact of the day. Boop. Each grain of salt is made up of exactly 39.34% of sodium and 60.66% of chlorine. Fun fact of the day. Boop.
The law of different proportion states, no matter how big or small the compound, they have the same ratio of elements inside. Whether you have 1 gram of table salt or the whole entire 100 grams of table salt, you'll still have the same amount, 40% sodium, 60% chlorine.
In 1808, an English school teacher by the name of John Dalton proposed an explanation for the law of conservation of mass and the law of definite proportion. He reasoned that elements were composed of atoms, and that only whole numbers of atoms can combine to form compounds. His theory can be summed up by 5 following statements. Number 1. All matter is composed of extremely small particles called atoms. Number 2. Atoms of a given element are identical in size, mass, and other properties. Atoms are different elements different in size, mass, and other properties. Number 3. Atoms cannot be subdivided, created, nor destroyed. Number 4. Atoms of different elements combine in simple whole number ratios to form chemical compounds. Number 5. In chemical reactions, atoms are combined, separated, and rearranged. John Dalton was able to turn Democritus' ideas into a scientific theory that could be tested by experiment, but not all aspects of Dalton's atomic theory have been proven to be correct. For example, today we know that atoms are divisible into even smaller particles, although the law of conservation of mass still holds true for chemical reactions. Drew Boyce.
The science guy.